So friends, in this video I will explain how the Lewis dot structure looks like for some of the molecules. So getting started with SF4. So here we have got the sulfur at the center and there is fluorine atom, 4 fluorine atoms surrounding this sulfur. Sulfur has 6 valence electrons, out of which 4 valence electrons are used to make the bonds with fluorine, and the remaining 2 electrons are shown here as a lone pair. And if you talk about the each fluorine atom, you can see that the fluorine is also completing the octet. So there are 6 electrons around fluorine. That means 3 lone pairs. Okay, 3 lone pairs. And there is this bond between sulfur and fluorine. Next one is BF4 minus. So here B is again central atom and there is a formal charge of -1 on this boron. So boron has 3 valence electrons, but it borrows 1 electron, and that's why it is able to make 4 bonds. So ideally it should be making only 3 bonds because it has got 3 valence electrons, but since it has borrowed 1 electron, he is able to make 1 extra bond with fluorine. And if you calculate the boron's formal charge in this Lewis structure, you can see that the valence electrons in boron is 3 minus lone pairs on the boron. So on the boron there is 0 lone pairs. Okay, electrons in the lone pairs is 0. Then 1/2 total electrons in the bond, 8. Right, there are 4 bonds, so in each bond there is 2 electrons, so there are 8 electrons. So if we divide this 8 by 2, there is 4. 3 minus 4, that is -1. That's why there is a negative charge on this boron, and that is also called as formal charge. Formal charge. And for the fluorine, you can see that there are 3 lone pairs and there is 1 bond between fluorine and boron. Let us look at the next Lewis dot structure for the ClF3. So we can see that for the chlorine, this is the central atom. There are 3 fluorine atoms surrounding this chlorine atom, and there are 3 bonds as well. So if you look at the chlorine's valence electrons, there are 7 valence electrons, out of which 3 are gone for making the bonds, right? So 4 are remaining, and those 4 electrons are shown here as the lone pairs. So there are 2 lone pairs over here on this chlorine atom. And for fluorine, we have got 3 lone pairs, and there is also 1 bond with the chlorine. Next one is AsF3. For As, valence electrons are 5, out of which 3 are used to make the bond with fluorine, and these remaining 2 are shown as the lone pair. And for fluorine, we have got 3 lone pairs, and there is this bond with As. Next one is Pcl5, phosphorus and chlorine. There are 5 chlorine atoms here, and at the center there is phosphorus. So for phosphorus, there are 5 valence electrons, just like As, and all 5 electrons are used to make the bonds with chlorine. So on the phosphorus, there is no lone electrons at all. There is no lone pairs. And for the chlorine, we have got these 3 lone pairs and 1 bond with phosphorus. Next one is XeF4. So Xe has got 8 valence electrons, okay, and fluorine has got 7 valence electrons. So out of 8, 4 are used to make the bonds with fluorine, and remaining 4 are shown here as the lone pairs. Finally, we have got SF6. So for the sulfur, we have got 6 valence electrons in sulfur, and all 6 valence electrons are used to make 6 bonds with fluorine. And this is how the Lewis dot structure looks for the SF6. Thanks for watching.